Hi, I was wondering if I could ask you a quick question. I'm not sure if you can hear me.
Yeah, I hear you. What's up?
So I'm taking a physical oceanography class,
Yeah.
and I have a question on my homework that actually,
Oh, okay.
yeah, it
What's the
pertains
question?
to the tides though, which we went over also in this class.
Yeah.
Um, and it's basically asking if the Earth's radius were doubled in size, but the mass of the Earth was unchanged, how would it influence the Earth's tides? So I thought it would decrease the tides, but I wasn't sure.
So the mass has increased. The mass is the same.
But the radius of the Earth doubled in size.
Okay. And with the same, current configuration of the no, so okay, if the mass doesn't change, well, what is it that drives tides?
Well, it's distance, like it's pull from like the moon and the sun and stuff, like it's distance.
Okay, well, so it's
Like the yeah.
okay, well, can you be a little more specific? Because I think that's what this question is encouraging you to do, is to think about what is causing tides and how they affect. So it's a bigger Earth, but the configuration of oceans and land is somehow all the same.
Right.
Right? And there's the same proportion of water and the depth of oceans and everything. Everything just increases proportionally.
hmm
Okay, so well, what is it that keeps the moon orbiting the Earth?
It's like gravitational like pull between
Yeah, it's the
like their attraction.
attraction to each other, right? So there's the moon and the Earth are actually orbiting around a common center, but do you from your reading, do you remember where that center is?
I think it's more in like the center of the Earth.
Yeah, well, is it the center of the Earth? I mean, you think so. Draw a picture in your mind of the Earth and the moon. So the moon is a tiny little thing, and it's, what is it, 240,000 miles away, something like that. And the diameter of the Earth is 240,000 kilometers, I think. And the diameter of the Earth is what?
I have no idea.
No, look it up. I think it's like 12,000 kilometers. Those are good things to know. What's the diameter of the Earth?
Uh, it says 7,917 miles.
Okay,
So
so that's about 12,000 kilometers, or convert that to kilometers. Let's do everything in kilometers. Distance to the moon. All right, so right now, the gravitational equilibrium, the center of the gravitational equilibrium between the moon and the Earth is somewhere
it's like a little off from the center of the Earth.
a little off from the center of the Earth. So if you double the size of the Earth, what happens to that center of gravity?
Would it go even a little bit further from the center of the Earth?
I'm not going to tell you the answer, but that's the way to think about that. So if that happens, if it got, can you sort of try to speculate about what would happen to the orbit of the moon?
I don't know if it would either like move with it, like it would go farther away from it, or attract further. I feel like it would attract. Like you know what I mean, like pull closer.
Right. Well, I mean, so if it's further from the center, I think you have to sort of diagram that out, and then you can change it a lot. So somewhere in your book there should be a picture of like a wrench or something showing you how the tide orbits. How the tide sort of moves around this, because the tide is moving around. The tide is not moving sort of around the center of the Earth. It's moving around that center of gravity between the two of them, between the two bodies, right?
Right.
So if that wrench, and that's kind of like the way people think about it is sort of as a wrench. That's a picture that, that's an analogy that's often drawn, made.
Mhm.
So the way to think about that is how that would change, you know, if the center of gravity were shifted outward from the center, more from the center of the Earth, essentially doubled, right?
Right.
So, okay, so that's my hint. I can't do
Thank
the
you. That helps.
problem for you, but that's my hint.
Thank you.
Okay. Asking about whether or not you were able to do the reading. So if you please answer the following poll. Of course, this is anonymous. And yeah, looks like most everybody has answered. Please go ahead and answer if you can. So it looks like okay, so it looks like most everybody did read the chapter 6, which is good because that's the material part of the material that I want to cover today. Looks like a lot of people did not read the sixth extinction, and so you need to go ahead and do that. We'll that because that's going to be the team assignment for today. So make sure you can access that and read through that, because you'll not be able to complete the assignment unless you read this this selection. It's a nice, or it's an interesting article. It's well written, and I think you'll get a lot out of reading that. Okay, so let me launch the share my screen here. And we'll start with the lecture for today. Okay, so we're covering chapter 6 in Hasenzahl, and the title of this is Biomes. And the questions that we're going to consider are: how does climate and geography affect biomes? The answers pertain to non-living factors, and what are the ecological characteristics of biomes? How do we quantify these characteristics? What are some factors: diversity, productivity, stability, and how is climate change affecting biomes? So, this is the material that's presented in chapter 6, and there's a pretty thorough discussion, and reading through there, it's all pretty descriptive, but there's a lot of information packed in there, and of course you're responsible for those things, those questions. What we're going to do, oops. What we're going to do today is look at the physical factors that affect Earth's biomes. And what I wanted to do is to compare the present configuration of biomes on the Earth and look at how that might have changed over time, because as we'll see when we look through this, that there have been very significant developments in how biomes across the Earth are distributed. And these long-term changes relate to physical processes, whereas a lot of what the book is discussing are sort of a present-day snapshot of how plants and animals are dispersed. And since we're discussing Colbert's article, The Sixth Extinction, we want to look at how events in Earth's past have produced extinctions. So this is a picture from the book, and this describes a series of major biomes: tundra, boreal forest, temperate rainforest, temperate decidual rainforests, and temperate grassland, chaparral, desert, savanna, and tropical rainforest. I guess what they don't show here is biomes, but which are very important are these ice sheets covering Greenland, ice sheets covering most of Greenland and just about all of Antarctica. So these ice sheets that exist today are remnants of ice sheets that as little as 20,000 years ago extended much further across particularly North America and Europe. And so the fact that there's very little life and we don't classify these ice sheets as biomes should be one indicator that our present configuration of biomes is a result of changes and adaptations, ecological processes that have taken place since the ice sheets retreated, essentially over the last 8,000 years ago or so. So, these biomes are caused by we define biomes are as broad areas and these are terrestrial biomes defined by temperature and precipitation. And temperature and precipitation, of course, are drivers in are a factor of increasing latitude. So as you move from the tropics to the higher latitudes, you tend to have a decreasing temperature and changes in precipitation. And the book poses the question, which of these triangles will be most affected by climate change? Well, the short answer is that the climate change is happening most rapidly in the high latitudes. So we can expect major changes in the high latitudes. However, the ecosystems and the biomes of the tropics and the temperate regions are susceptible to changes in climate, particularly because of the high levels of biodiversity that they're experiencing. So we wouldn't expect the biomes of the higher latitudes to be as impacted in terms of causing major extinctions or major changes in species immediately, whereas the changes in climate can have and are having, profound effects on the distribution of plants and animals within the lower latitudes. Okay, so that's a sort of a present day picture. And what I wanted to do in the period of time that I'm going to be talking today is to go back and look at, throughout the history of Earth over the last 550 million years or so, and point out that what we're seeing today is very much a moving target, where we have a distribution of Earth biomes, distribution of Earth climate, that is a result of factors that have been changing continually over geologic time. And so when we consider, where we are now and where we might end up as a result of things that are driving the climate into different configurations, different statuses, then we have to think about, we can try to understand that based on what we've seen in the past. So, one of the major, and it's frequently the case that when people talk about climate change, and in particular people who are trying to downplay the impact of climate change, one common theme that emerges again and again is to say that climate is cyclical and that the climate has been changing all the time. Our governor has said that, our president has said that, many politicians have made this statement. This is a sort of a sophist kind of statement. There's certainly a strong element of truth to that. What's missing and what's fudged is the kind of timescales over which these changes have occurred in the past. So the cyclicity, the length of the cycles over which climate has changed in the past, and how these timescales affect or relate to the human timescale, which is vastly shorter than the timescales over which time has changed. So it turns out, if we look back through the history of the last 550 million years, that the different cycles in climate are very much related to a very long-term cycle in the configuration of continents and oceans across the planet, which is referred to as plate tectonics or plate tectonic theories. And you're familiar with this, I'm sure, this idea that at about 200 million years or so ago, all of the present-day continents were joined together into a single landmass, a single supercontinent, and that at some point or another, this continent began rifting, breaking apart, with the result that the supercontinent broke up into smaller continents, and ocean basins formed in the areas that opened up between the continents. And the evidence for this, this of course produces some profound changes in the sorts of plants and animals that occur. And we can see this in terms of the areas where there's overlap and the areas where there's a gap between the continents. And we can also see it in terms of divergent evolution of major land, animal and plant forms in the two continents. And so the classic example of how divergent evolution between the North America and Africa occurred, so what we would call the old world and the new world, although that has no meaning in terms of plate tectonics. But old world apes, monkeys, we're familiar with, of course, are arboreal. They live in trees. They're very agile and they're able to move. They have grasping appendages. They're able to hang like this. However, it's when the two continents rifted apart and drifted apart from each other, the populations of monkeys living in the two sectors, now separated, began to diverge evolutionarily. And so that New World monkeys, unlike Old World monkeys, developed a prehensile tail. So this is a trait that Old World monkeys did not have, and this is as a result of evolution of the monkey primate landform animal forms that were present in South America when the two land masses diverged. And there are many other pieces of evidence. The plate tectonics represents a paradigm shift in our understanding of how Earth developed and changed over time. And there are many other lines of evidence, glacier deposits on portions of land and continents that are now warm. So you can find evidence for glacial deposits in South Asia. You can find glacial deposits in Africa. And obviously, in the present day, there were no glaciers in these regions, and identical fossils, divergent life forms, and so forth. So there are many lines of evidence that demonstrate that plate tectonics is a factor, is a process, which is determining the configuration of land masses and oceans. And this is known as the Wilson cycle, and it takes place, it's about a 100 million year cycle, more or less. There have been about a 500 million year cycle, so there have been about 8 or 9 in the history of the Earth. 3 billion year history of Earth. There have been about 8 or 9 times that this cycle has repeated itself. And so the stages of the Wilson cycle or supercontinent cycle are shown here diagrammatically. Initially, you have a single landmass. This rifts apart by processes related to transfer of heat from the center of the Earth into the area between the two continents. When they rift apart, the water floods in and forms an ocean basin. The two continents continue to rift apart or move apart because new ocean seafloor, new oceanic crust is forming in the area between the continental land masses. Over time, these, if you track the two divergent plates, the edge of the plate is what we would call passive. There's not further geologic activity taking place, but there's not tectonic activity taking place in the divergent land masses. But where the land masses meet each other and where the ocean plate meets land masses, you get subduction taking place, and the subduction over time builds up, causes formation of volcanoes and other effects. And in time, the continental plate, which had rifted apart from an earlier supercontinent, drifts back together and remerges. And so this is the Wilson cycle. It's about a 500 million year cycle. And so if we think about the last 550 million years of Earth, we sort of came to the end of one Wilson cycle, and we're sort of in a stage in which most of the continents are rifted apart. Well, so what does that mean for us? How does that affect us? And so here's a sort of a diagram of this, these changes in the continents, since over the last 175 or 200 million years. So, and what's drawn here are not just where the continents are, but how the circulation of ocean waters is influenced, is steered and guided by how these continents are arranged relative to each other. So you can think that if there's a single slice of land going from the southern high latitudes to the northern high latitudes, then oceanic circulation is going to be impeded around that. Conversely, when the continents rift apart, you get changes in seaway passages that allow for very different sorts of oceanic currents to occur. And so in our present day world, well, this is 30 million years ago, you can see that there are slices of land. There's a seaway going through at the a southern seaway, which we call now the Southern Ocean, and there's also a mid mid Earth seaway that passes through here, through the near the equator. And these different configurations of oceanic circulation have the result that there are profound changes in the way that heat is transferred or not transferred from the equator toward the higher latitudes. And this fundamental difference has the result that if we look back in time, we had the kinds of climates that are possible now could not have occurred at earlier times. And so we've had very, very different, fundamentally different climatic changes on Earth, and very different distributions of biomes. It's kind of a truism to point out that as 30 million years ago, there were crocodiles and tropical plants in the high latitudes. So that's a very different sort of world than we have today. We can see changes in this. So this is sort of, again, diagrammatically, different kinds of configurations of the planet depending on whether there's a seaway and where the seaways occur. So one of the better descriptions of the world that we're living in now is a polar world with ice caps. And so here we see the average surface temperature and by latitude. So 0 latitude is the equator, and 90-degree latitude, of course, is the North or the South Pole. So in a polar cap world, we have a warm tropics, warm near the equator, but very cold in the high latitudes. And so this is on the left-hand side, the left-hand diagram here, this is a sort of a theoretical presentation of what a tropical ring world and other worlds would look like. And on the right-hand side here, we can see the present northern hemisphere and the present southern hemisphere. So the two hemispheres have different climates, obviously, although they're similar in the fact that there are high temperatures in the tropics and low temperatures in the high latitudes. And you can see also here that in a tropical ring world, you would have the possibility of the highest temperatures at the equator. So this, I'm not going to talk about this too much. So here are some different other descriptions here. And so, one way to think about our present world is we're in a double-sliced world with high latitude seaways, although we don't have an open seaway all the way around the globe in the northern hemisphere. So that difference is one of the reasons that we have a different climate, or a divergence in climate between the northern and the southern hemispheres. We can also see that there's been a temperature change and how this has affected different times in Earth history. So if we start with the Quaternary, which is the last billion years or so, and go backward in time to the Cambrian, about 540 million years, this has been the change in temperature on the planet. So we've had periods of very cold times. Carboniferous and Permian times were much colder than they are at other times. Generally speaking, the planet has been hotter than it has been in present. So when you have these, when you have these periods of very low temperature, the Earth is covered with ice sheets to a very large degree. Now, this is called the sort of snowball Earth, or ice world, and this snowball ice world can extend pretty far. Doesn't cover the entire, well, there's different theories, but it covers large fractions of the planet. Okay, and we can see that the present, the last million years or so ago, we're actually quite a bit colder than we have been, going all the way back to the Jurassic and Triassic time. So we're, compared to Earth's past, our present day Earth, or the Earth as it's been, as it's existed over the last 100,000 or million years or so, is quite a bit colder than it was in the past. And since we, with climate change, are reversing that trend, and we're sort of headed out of that cold period with increasing melting of ice caps, we might expect that the climate and the distribution of biomes would revert to something more different in the past. Okay, so this process of plate tectonics and ocean basin formation, rifting, and so forth, this gives rise to very different configurations of the land masses and oceans, and as a result, there are very different conditions of heat transfer from the tropics toward the high latitudes. And this has a profound influence on long-term climate. And we can see, if we look here, that the numbers of families and the numbers of changes in the time before present. So this is a sort of, this diagram here is looking all the way back 550 million years ago into the numbers of families. And we talked about families in terms of, the way we describe life forms. So this is taxonomic families, the numbers of families on the planet. And then there's a sort of a trend of steady increase. So there are more and more different varieties of life, higher and higher biodiversity. And that trend of increasing biodiversity has been, in play since the emergence of multicellular life in the early Cambrian, but it hasn't been a steady increase. So there have been different impacts over time. So that's another view of the long-term changes. Well, I've talked about how the Wilson cycles, or the supercontinent cycle, influences the transfer of heat from the tropics towards the poles, and has a determinant factor on the large-scale global climate. Well, there are other factors, other processes that operate at somewhat shorter time scales. And I'm going to look now at two factors. One is mountain building, and then the other is what are called Milankovitch cycles. Changes in the orbit of the Earth around the sun, which have an influence on climate and temperature over shorter time scales. So one of the events that occurs when continents collide as a part of the supercontinent cycle, the Wilson cycle, is that where continents collide, you get mountains that form. And so a great example of that is the Indian, so quote unquote, Indian subcontinental landmass, which about 71 million years ago, as a process of continental movement, began drifting northward until it collided with the Eurasian plate. And so that's something that took place, over 70 million years ago. And about 10 million years ago, India ran into this plate, with the result that the two colliding land masses were forced upward, and this formed the what's called Tibetan Plateau, the Himalayan mountain range. The Himalayan mountain range is the largest and highest mountain range on the present day Earth, but it is a relatively recent feature of Earth's history. So only over the last 10 or 15 million years have we had anything resembling the Himalayan mountains. Well, what happens when you form new mountains on the Earth? Well, it turns out that mountains have a huge impact on climate over a sort of 100,000 to million year time scale. Several things happen. There are changes in seasonal climate. And so, for example, the monsoon rain pattern, where you have dry periods in the winter and fall months, but then starting in the summer, the change in temperature over the increase in temperature over the Himalayan plateau causes a wind patterns that bring winds from the Indian Ocean over the Indian continent. And these winds and this movement of climate creates massive rains, monsoonal rains. And so seasonal climate changes are very much dependent on what kind of landmass you have. Other factors that are influenced by the existence of mountains are the formation of very large areas of snowpack or mountain glaciers. And these mountain glaciers store large amounts of fresh water, which then runs off the mountain during summer melting and provides fresh water for the non-mountain, the lowland areas below the mountain range. And so there are probably 1 billion people in India and Asia who depend on runoff from the Himalayan mountains for their water supply. And so changes in the loss of the snow cover and glacial mountain glaciers in these regions is going to have and is having a huge impact on the availability of fresh water for the people living in this region. Similar processes are taking place in the Andes Mountains, where glaciers are melting, and as a result of the loss of this cycle of snow formation and then melting, there is a threat to the availability of fresh water, which of course impacts human beings, but also impacts the kinds of biomes that can occur and the availability of fresh water for these biomes. So mountain building, I said, that the Wilson cycle, the supercontinent cycle, is influencing climate over a roughly 200, 500 million year time scale. Well, mountain building is affecting climate over a 10 million year sort of time scale. If we're moving ahead to shorter time scales, another process that changes, this kind of slide is out of order here a little bit. Let's see, this is the slide I wanted to show. The other process that drives changes in the climate over the last 100,000 years or so are what are called Milankovitch cycles. So Milankovitch cycles are changes in the orbit of the characteristics of the orbit of the Earth around the sun. And there are 3 different types of climate, types of variability: precession, obliquity, and eccentricity. And so the shortest time scale is precession, which has roughly a 40,000 year cycle, or 20 to 40,000 year cycle. And what this is saying is that the Earth tends to wobble on its axis. And as a result of this wobble, there are changes in the average temperatures because the Earth is tilting more or less toward the sun, and this affects the distribution of heat arriving from the sun. Over a 40,000 year time scale, obliquity is a result of the a change in the orbit of the Earth around the sun. So, this is a hugely exaggerated picture, but the Earth orbits the sun in a oval formation, in a elliptical path, and this elliptical path over the 40,000 year time scale can become greater or lesser, so that the greatest distance of the Earth from the sun can increase or decrease over these time scales, and that can cause changes in the Earth. and you know, and then over the longest time scale, about 110,000 year time scale, is the eccentricity. So the path of the Earth changes, and the result of that is changes in temperature. So these changes in these are purely physical factors, and the Milankovitch cycles result from cycles in the gravitational effect of the giant planets in the solar system, Neptune, Saturn and Jupiter. And so these you know, pull the orbit of the Earth in these very tiny ways, but in terms of the change in average temperature, they are affecting the Earth and the Earth climate. We'll talk more about Milankovitch cycles and their influence on Earth climate when we look at climate change in subsequent chapters. What I wanted to do here was to present these different changes and these different timescales of changes that have nothing to do with the adaptation of life, the evolution of life, or the formation of ecosystems and biomes, but they very much determine what sort of ecosystems can occur. The point of the reading here was to look at what are called extinction events that have occurred in this period. And so these are events that sort of interrupt these larger cycles. And there have been 6 extinction events, 6 great or 5 great extinctions in the past. And, you know, arguably we are in the middle of a 6th extinction. And, you know, this, you know, where they are, you know, what you call an extinction event is a little bit of a fuzzy definition, but these are the commonly accepted extinction events. So the Ordovician-Silurian extinction event, and take note of the fact that very often these events occur at transitions between geologic ages. And so, you know, we have Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, Cenozoic. So these are geologic ages. And very often these extinction events occur at the transition from one age to another. Well, I've been telling you all along that, oh, you know, the climate of the Earth and the possibility of distribution of biomes and so forth was determined by these large-scale cycles. But then you have this shift in you know, these extinction events that are occurring at the transition between these geologic ages. So what's going on here? Well, it turns out that geologic ages are, and the fossils that occur in geologic ages are how we define these major periods of time. So what's happened at these events? Well, there are a variety of things that can cause changes. Very often, or almost always, there are signals to do with massive and catastrophic changes to Earth's atmosphere. You know, in this case, the Ordovician-Silurian extinction event was a cold period, and so glaciation, you know, the abundant life removed carbon dioxide from the atmosphere, causing global cooling and glacial formation. Sea level dropped as a result, and there was a shift from organisms adapted to warm temperature to organisms adapted to cold temperature. And the other kinds of extinction events have occurred. The Permian Triassic event was one of the greatest extinction events. This was 96% of all life on Earth perished. And they believe that, scientists believe that volcanic activity produced massive amounts of carbon dioxide and other greenhouse forcing gases, which you know, really made Earth basically uninhabitable. And so large, you know, the ocean became acidic, and both the land and the ocean was far less hospitable to Earth. You're probably all familiar with the KT boundary event. This is the division between the Cretaceous and the Tertiary period. It's called the KT boundary event because in German, Cretaceous is spelled with a K. So the Cretaceous-Permian boundary event, which wiped out the dinosaurs, is widely believed to have been caused by the collision of a large comet with Earth. This occurred suddenly, unexpectedly. The impact point in the comet was the southern Gulf of Mexico off the coast of the Yucatan. And this event caused this huge impact. There were shock waves that were felt around the Earth. There were giant tidal waves that inundated land in a matter of hours or days, and life was completely disrupted. So this is thought, or this certainly coincides with the disappearance of dinosaurs and the dominant life forms of the period. After the KT boundary event occurred, dinosaurs didn't come back. Their only living relatives are birds, and there are plenty of birds around here, so birds were able to survive. But another dominant animal group emerged, namely mammals, and this mammalian radiation of mammals continued from this period all the way to the present day. And then the Holocene extinction, which is taking on place right now, is a result not of a volcano or snowball Earth or other kinds of impact of a comet, but the impact of a particular species, human beings, on the available biodiversity. So this is a different sort of extinction event, and this is what's referred to as the sixth extinction, and this is discussed in the article by Colbert that we're reading today. And I would just like to point out that we think of volcanic events and volcanic disturbances affecting the entire planet as something which has occurred in the past, but there have been in recorded history similar sorts of impacts from volcanoes that have affected the Earth. The Laki eruption is very widely celebrated. This occurred in 1782 and 1783. So the summer of 1783 was the harshest on record. Most of the population of Iceland, where the volcano occurred. So this is the Laki volcano here, and this is the part of the rift zone. This is where this volcano occurred. This Iceland sits right on the mid-ocean ridge, the suture which separated North America from South America. So this is a very geologically active area. And in 1783, 1784, this volcano erupted. It was a massive eruption. It poisoned the atmosphere. Probably killed at least 25,000 people in Britain, equal numbers on the continent of Europe. The winter of 1783, because the aerosols that had been released by the volcano were still present in the atmosphere. They blocked the sunlight. And so the winter of 83 and 84 was extremely harsh. Benjamin Franklin documented this. And there have been other events. And this Laki event may have coincided with El Nino and other processes of global climate change. And as a final note, I'll just point out that this period, 1783, 1785, this was a period of extreme political disruption. So the French Revolution occurred right in this period here, and the French Revolution was an outgrowth of famine on the European continent, and that famine was very much a result of the failure of crops during this period here. So, we can see that that these sorts of non-living events caused by geologic and other forces can have a profound influence on climate, on the evolution of life forms, and indeed on political factors. And so it's interesting to think that we are in the present day living through a massive climate change, and these massive climate changes are going to no doubt produce political consequences, going to have political consequences for our present day society. All right, well, that's as much as I wanted to present. I want to leave enough time for you to divide into your groups. Before I do so, I'll ask if there are any questions over the material that I've covered here. I know I packed in a lot here, but I did want to offer some perspective on the way it's described in chapter 6, because chapter 6, really just sort of presents a snapshot of the present day without discussing the factors which drive this, and also without informing us about how the distribution of biomes and the changes that climate change is inducing on these biomes, and what we can learn from past events to try to understand what's happening today. So, are there any questions over the material that I've covered in the last half hour or so?
So are we at like the end of our era? Like, you know how the end of the Cretaceous era was the start of the next one? So really like the end of the current one we're on?
Well, yeah, we're at the end of the Holocene. So the Holocene is the period, so prior to, Earth civilization, and, human beings first emerged, 2 million, 3 million years ago. Modern human beings about 200,000 years ago. Truly modern human beings, about 100 to 175,000 years ago. And, human society, was very much limited by ice cover. And so 20,000 years ago was the time when there was the maximum ice cover across the North American and European continents. And during that time, there was existence for our human ancestors was very much challenged by the extent of the ice, by the very harsh climate that was present. Well, the last glacial maximum, LGM, that's referred to, that was about 20,000 years ago, and that ice sheets began melting, and by the end of 13,000 years ago, 14,000 years ago, really the ice had effectively really retreated. And with the retreat of the ice sheets, the land that was left was, the land was exposed when the ice was retreated, had to go through this primary succession. That primary succession was something we discussed in an earlier lecture. So that primary succession gave way, and the retreat of the ice sheets gave way to a period of very stable climate, lasting, roughly over the last 10,000 years or so. And that period is referred to as the Holocene. So Holocene is, the last 10,000 years have been a time of relatively stable climate, and really a kind of a period in which life forms were able to evolve and emerge, and more importantly, global ecosystems developed and took on their present day form. Well, we have now left the Holocene, and we've entered into a new geologic age, and there's a lot of argument about when exactly this occurred, and what the marker for this transition is. But we now have stopped referring to the climate period that we're living in as the Holocene, and we're into a new period which is called the Anthropocene. And if you know enough Greek or Latin rather, you'll know that this refers to human beings. So we're in a period in which human beings are the major driver of the climate. And so yes, we are in a transitional period, and that transitional period is taking us into really uncharted territory. That was a long answer, but I hope that covered what you were concerned about. Other questions? No other questions? All right, well, let me stop sharing, and I will split you into your breakout rooms. And in your breakout rooms, you're going to escape. You're going to be talking about this book here, this article by Elizabeth Colbert. And so I'm going to open all the rooms now, please. If you're not in a room, let me know. And let me see. So Caroline, I'm going to try to make you so Carrie, I'm going to try to make you a co-host. And hopefully that'll allow you to move from room to room. Let's see, Carolina.
I'm in the Planeteers.
Planeteers.
I'm also in the Planeteers. It just kicked me out.
Oh, I'm sorry, who's speaking?
Gwen, sorry.
Okay, Planeteers. And Darren, you're in Aquatic Junkies. And Emily, where do I put you?
At the Wayfinders.
Wayfinders. Kate,
Team title.
Team Title. Whitney, Planeteers.
Green Machine.
Green Machine. Why don't I remember this? And Carrie, where should I put you?
Wherever you need me, and I'll see if I can move around.
All right. So, okay, so I withdrew your co-host permission and then I added it back. So maybe that'll allow you to bounce from room to room.
We'll see.
Can you put me in the Aquanauts, Laura? LaChapelle?
It says you're in the Aquanauts. Is it not letting you join? You're assigned to the Aquanauts, Laura.
There it is. I see it. Okay, thank you.
Sure. Are you able to move? It says you're not joined.
Yeah, no, it's not letting me. So I guess I'm just gonna leave and then come back and we'll try it.
Okay. Let me try. Yeah, so it's not letting you move. Yeah, you might need to log off and log back on again.
Okay, yeah, because it's not doing it. I'll be right back.
Ellie Rill. Hi, Ellie. Are you here? Can you hear me? Okay, Laura, I'm going to put you in Aquanauts, right?
Yes. All right, it's working. Thanks.
Hello, Clams. I'm here to check up on Carrie, see if she's able to move in and out of other groups.
Yeah, she was just here.
Okay. Carrie, are you still here? Could you get out and get back into someplace else? So all right, so Carrie and I have been trying to work out so that she can do this independently. So let me leave the room. Well, Beaches, are you doing okay here? Did you get a chance to read this article? What'd you think of this article? Kind of an eye opener, huh? Had you already heard of this concept of the sixth extinction?
I haven't heard of it before until I read the article, so it was very interesting.
Yeah. Okay, well, so, I'd like you to, it was written in 2009, so I'd like you to sort of expand and kind of fill in some of the things. And she's writing it for the New Yorker, so it's very much for a popular audience. If you dig into it, and she does a really good job. She's an excellent writer. There's a book, she just expanded this article into a book called The Sixth Extinction. And she, I always find her stuff very thoughtful and well informed, but she always puts in kind of, descriptions of the place that she's going and, how they travel to collect the frogs and, where they go into the caves to look at the bats. So it gives it a lot of sort of color and interest. But, sort of digging into the science about the frogs and the bats, you'll notice that there's a theme about what's driving the sixth extinction, which is really, she talks about disease events. So both for the frogs, there's one sort of pathology, and for the bats, there's another pathology. And that's different from, it's 2,000 years. So this is 2009. So this is a different theme from the sort of climate change impacts that we're seeing today. And one thing I'd like you to do is sort of develop, that distinction. So keep that in mind as you think about this. All right, I'm going to move on to a different room, unless you have questions for me. Okay. All right.
for that exam because there's just so much information. And
Hey, Professor McDonald. So we were wondering about our midterm and what that's going to look like, and if you're going to talk about it at all.
I was planning to talk about it when we get back together,
Okay.
but don't be too nervous about the midterm. It's going to be heavily weighted for the questions that have been in the reading quizzes. So if you're doing well in the reading quizzes and you've learned that material, that should put you, give you a solid foundation. The other part of the reading quizzes and then the team essay things, most of the exam is going to be taken from there. But, I give you little lectures every day, every time, and I'd like to think that you all are paying attention to that. So some of the questions on the exam will be taken from the material that I presented in my lectures, okay? So, that material is covered, of course, in the PowerPoints that I share, and hopefully in the notes that you take. And I'll make sure to outline when I put together the study guide or the study suggestions for the exam. I'll make sure to notify you, what sort of themes I'd like you to be familiar with based on my lectures. Because my lectures, I try to design them so that they go into a little bit more detail, take a slightly different tack from what's strictly in the book. Does that make sense?
Perfect. And are you going to do honor lock or like just time, really short, normal?
I haven't totally decided. I don't like honor lock. I've seen problems with honor lock. And so I'm skeptical about honor lock. I'd rather, design the exam in such a way that, you have to answer lots of questions. And so it's hard to use it's hard to cheat that way. And then you have it be essay questions where you can't really look up the answer. You have to think. Okay, so that's my plan.
Cool. That's good.
All right. Sorry. Let's see you in a bit. Hello, junkies. How are you doing?
We're good. How are you?
And
Had you guys heard about the sixth extinction? Is this a new concept for you, or is this something that you've seen before?
I'd heard the term before. I didn't realize that amphibians were falling off the face of the earth in
Yeah.
such masses. That part I did not know, and it's a bit shocking, actually.
Yeah, well, it's not just the only group that's falling off the cliff. So this is 2009, and this idea of a whole order sort of suddenly being impacted on a global scale, was really a shocker for everybody. But since then, and this is what I'd like you to dig into, there have been other findings of groups, and there's something called the insect apocalypse. Have you heard of that?
I've heard of insects, like every day a bunch of insects just die, especially in the Amazon. Like every day there's a new extinction of insects. But we
Yeah.
don't even we haven't even classified like a lot of insects though. So it's like, I don't know, it's ridiculous.
It is pretty ridiculous. Well, I don't know, ridiculous is the right, I know where you're going with that. But, there are other sort of large scale findings that are emerging. And this is, I'd kind of like you to look this up. And I think I mentioned this in one of the prompts, is to look for, large scale extinction or disappearance of groups of organisms, insects, birds, mammals, etc., that are really kind of unexpected. And so look up the insect apocalypse and you'll find some really interesting details, which will help you to answer that question. Okay, any questions?
No, sir.
All right.
What's the theory?
Hendrix on a CD player. We bounced along to the throbbing beat. What the fuck is this?
My favorite one is about the herpetologist couple that put all the frogs in like hotel rooms. That was the best part.
So hi, Tiktalix, how are you doing?
We
have you guys heard of the sixth extinction before?
I have not.
No.
Okay, so this is a sobering piece of information. And, Elizabeth Colbert describes it in one kind of way. And, then the book is asking these questions about how climate change is affecting extinctions. And so, think about how, what Colbert is describing for the amphibians, frogs, and then bats. That's sort of one kind of driver in extinction, large scale extinction. But there are other drivers. And so think about which, have kind of begun to emerge, in the last 10 years or so. So in particular, I'd like you to look at be aware of what's called the insect apocalypse. And then there's also, the disappearance of pollinators and other questions like that, which are, what's shocking about the amphibian problem with the BD is that, it's affecting all these different species in all these different areas, and it seems to be so unstoppable. And so, kind of keep that in mind when you're thinking about other processes that are going on, other kinds of events that are happening.
We have a question for you.
Yeah, in question number 2, it says, in question number 2, it says, what is the theory for?
Yes.
What is that asking?
Oh, I'm sorry, I didn't fill that out. What is the theory for why they're disappearing?
Oh. That
I'm
helps
sorry,
a lot.
that's
we were doing lots of guessing. So.
Okay, well, I will, yeah, let me, I'll put that in the chat so everybody knows. And thanks for pointing that out.
Yeah.
I don't know, you have to.
Mary, was that your question too?
Yes, it was.
Yeah, good. I didn't want to cut off.
No, you're totally fine. I just wanted to make sure we remembered to ask. Okay.
Well, that makes more sense now.
And I think we answered it too.
Yeah.
Okay, I put that in the chat. Thanks for that, pointing that out. And okay.
Thank you.
Hello, Tyler.
Hey.
Hey, I'm sorry about question number 2. I was typing away there and I left out some of the words, so file a complaint. Anyway, so you see where I filled that in. I said, what's the theory for why they're disappearing? That's what I wanted you to answer in that question.
Yeah.
Figured that out. All right, good.
Okay. Yeah. We got all the responses.
Great. Had you guys heard of the sixth extinction, this concept of the sixth extinction before?
Oh yeah.
Yeah, okay. Some people have, some people haven't. And what I'd like you to do is to, so in this article is in 10 years old, even more than 10 years old. And there have been other sort of equally troubling changes in, the diversity of different groups. And in particular, the insect apocalypse, something that's referred to as the insect apocalypse. And, look that up. Because that's also very sobering. There are also big changes in, birds and so forth going on. And they may have, the cause of the amphibian apocalypse, was this, one particular, factor, this fungi, fungus. And, but the, the reason for why insects are disappearing on large scale is, is really puzzling. There's niconoid pesticides, which are probably causing bees to disappear. And it's possible that niconoids have a, an equally impactful effect on, other insects. But the population of insects has dropped by about 75% in studies done in Europe, which is a, a truly shocking number. And not something you think about. So, dig into that, see if you can learn something about that. Okay.
Cool. Thank you.
Okay, welcome back. I guess I'm curious how many people had heard of the sixth extinction, this concept of the sixth extinction, and how many people are learning about this for the first time. Who hadn't heard of the sixth extinction? Lots of people.
I haven't heard of it.
Yeah, okay. So this is very sobering, and really sort of troubling, and makes you, I don't know, makes me feel guilty about being a human being in some kind of weird way. And But the sixth extinction that Elizabeth Colbert is describing, you know, both in the bats, disappearance of bats, and then the disappearance of amphibians, you know, this is related to sort of pathogens in the environment. You know, white nose disease for the bats, and this BD fungus for the amphibians. But if you update the findings of, you know, disappearance of large groups, there are other, you know, similar sort of trends that are occurring that are equally disturbing that people don't really understand very well. And, you know, one thing to look for is what's called or what's referred to as the insect apocalypse. So if you look up the insect apocalypse, you'll see that there has been some, you know, really troubling changes. And so will help you to answer the other questions. Okay, so what I'm going to do now is to call on the different teams and ask you in the few minutes that remain, you know, how to respond to the questions that I ask. And everybody got that I left out the text there in question 2. So what is the theory for why amphibians are disappearing? Okay, so I'm gonna spin the wheel. And Green Machine, Can't Fathom, and Wayfinders answered the questions last time on Thursday. And so we'll give some different teams a chance to talk. So Beach, please. Beach, please. Would you join the fun and tell us what you learned? So what is an extinction event, and how does that differ from the disappearance of a single species? How did you answer that question? Somebody jump in. Beach, please. Okay.
I said that an extinction event is like a period of mass extinction instead of just the extinction of a single species.
Okay. And I guess the other important component of that, just as an aid to everyone else, is that it's a mass event and it's caused by some, some change, some, process or event that, makes the planet less inhabitable on a large scale. So extinction events are large scale disappearance of numbers of species or numbers of families. Okay. All right. Any other comments on extinction events and what you were able to find from the beaches? Taylor, Delaney, what did you learn about?
I have a question. In terms of like defining extinction,
yeah,
that would be more of a like a complete eradication of, say, a species, but one that's extended into like more than a species, like a type of organism.
Mm-hmm.
Are there certain like qualifications that change between extinction like of a species and extinction of like a whole type? You know what I mean?
Yeah, sure. So kind of embedded in your question is the how do we describe? How do we know that there was a large-scale disappearance? How do we know that an extinction event occurred in the past, right? So that would how do we? What data can we use to define that? And what the people who study this look at are the fossil record. And so, we can drill down into, fossils, and we can date those fossils using a variety of methodologies. And so we can see, if we look, into the past by drilling into rock, or, looking at different layers that are exposed, we can see how many species there are, how many species of animmites, how many different kinds of mollusks and so forth. And so, what an extinction event is and a lot of these species are not, or a lot of these life forms are not well described. We don't necessarily have species for everything. So what paleontologists do is they look for the number of families or the number of genera in a particular era. And so if they see an abrupt disappearance of more than 50% of the families or genera that were present at a certain time, they say, okay, and that occurs abruptly, well, that's an event, and that's an event which, which qualifies as a large-scale extinction event. So it's the disappearance 50% or more of, the taxonomic forms in a particular time over a relatively short period. So when you see that diagram that I showed of the extinction events, like in the, the Permian Triassic extinction event, well, it looks like this sudden dip, but you have to remember that that graph is, over a period of hundreds of millions of years. So, over a period of, tens of millions of years, we see this drop in the numbers of fossils that are present. And the resolution, the degree to which we can refine or define changes over time as you get further back in time becomes much more coarse. And so extinction events, typically take place over, millions of years. So like the Permian Triassic time period, that lasted 10 million years. And of course, that was a very, very bad period in Earth history. 96% of the genera wiped out. The present day extinction event is occurring at lightning speed, compared to what we know about in the past. With the possible exception of the snowball, or the comet, hitting the Earth. Well, that was one event, sort of at a particular time. There's controversy around the KT boundary event because there were other things that were occurring in that same period that were probably had the result of making life, less successful. So there was large-scale eruption of volcanic activity in India, in the Indian continent, which is producing changes in the atmosphere that was probably very damaging. But you nonetheless had that abrupt event of the impact of the comet. Well, we have this abrupt event of the impact of human beings, which essentially is occurring over the last couple of hundred years. So compared to events in the past, it's very rapid. And the causes are the explosion of the population of this one particular species, human beings. Does that answer your question, more or less?
Yeah, quite well.
Okay, let me call on another group here. We got a few minutes left. Well, I guess we don't have any minutes left. So we'll continue this discussion. I'll leave more space for team discussion in Thursday's class. So make sure you answer all the questions and come prepared. I'd like you to consider, what kind of education. So we would like to do something, I think, about the extinction events. And so what could we do? How would we educate? How would we convince people that it matters whether or not, there are frogs or polar bears or insects? And so, as you're thinking about, learning about this concept and finding examples in the literature, keep in mind, how we can use that scientific information to try to educate the public and convince people that it matters, that preserving biodiversity, preserving species is something that, that we should care about. All right, I will end the class. I'll keep going here until the top of the hour. And if there's any other questions or discussion, you're welcome to bring up any topic related to the course. I had some questions about the exam, and you're welcome to ask about that as well.
How would you address the idea of trying to convey the importance of this extinction, or
Well,
just to the general public? I mean, like to show like an understanding of how this impacts like our own lives,
mhm.
or because like relatively like the loss of one species of frog in the middle of the Amazon rainforest doesn't affect everybody.
No.
But I guess it would be more on the processes of how that's happening that would be more influential. But even then, to convey that to like the people, or like just people in general, how would you make that like a lasting impact?
Well, I think one thing to do is to look at, ecological services. This concept of ecological services, that human society benefits in multitudinous ways from the existence of a healthy ecosystem. And, species and biodiversity is the foundation of healthy ecosystems. And so if you can find concrete examples where a shift in ecosystem health produces, changes that are impactful, one good example are these invasive species impacts. So these invasive species impacts can have huge consequences for, tourism and agriculture and land use, forestry, and so forth. And so, that's certainly an argument to make. The disappearance of pollinators, so, not only are bee populations, honeybee populations really under threat, and, people who may, who raise honeybees and use them, rent them out to pollinate agricultural crops, are having major problems with, sudden colony collapse is what they call that, where the whole bee colony, disappears suddenly. Has a real impact on, the ability of bees to pollinate crops. And so the agricultural productivity, if we didn't have bees and pollinators, would really crash. And so there are also natural pollinators that are vital for the ecosystem. So that's one example of something, where a ecological service being offered by a particular life form, is something that we derive benefit from, and its disappearance would have an impact. So that would be one way to approach that. I would look, sort of more generally at changes that would impact ecological services or ecological well-being. So that's my suggestion. Any other questions or comments on this this concept of the sixth extinction? Any other thoughts? I see you have roommates there, Taylor.
Yeah, the other one's from Gainesville. He's visiting for the week, and they were messing with me this entire time. So
thanks, friend.
Yeah, right. All right. Well, I guess that's it for me. Thanks, Professor.
Sure. Any other comments? You all can activate your video if you want to hang around.
I have a question about the exam.
Okay, go ahead, activate your video.
Are we going to be using honor lock for the midterm?
I haven't decided. Probably not.
Okay.
I don't like honor lock. I don't know. What do you feel about honor lock? Have you taken exams with honor lock?
I have, and I do not like it. One main reason is you have to clear off your desk, and my desk has a lot of books and stuff on it, and it takes a while.
Uh-huh. So I sat on the honor court, and there was a student accused of cheating on an exam, and this exam was given by honor lock, and it just seemed like that you had to. It kept locking, kept freezing on him, and so there were issues where it made it hard to understand. It made it hard to really determine what had actually taken place. He might very well have cheated, but it was hard to figure out based on honor lock. So I'd rather configure the exam in such a way that you have to answer. You have to know something to be able to answer the questions.
Okay.
The exam is going to be heavily weighted towards the quiz questions. reading quiz and the reading essay questions. So if you've done all that and you feel like you know that material, you've got a good foundation for doing well on the exam.
Okay, thank you.
Sure.
I'll see you Thursday, Professor.
Okay. All right. Well, it looks like we're all leaving, so I'll end the recording now. And see you on Thursday. Hey, Carrie, are you here?